Hi guys, this is Sanjay, CEO and co-founder of Dhruva Space.
Hey guys, this is Chaitanya, CFO and co-founder of Dhruva Space here.
Space, the final frontier. You might remember these iconic lines from the Star Trek series and movies. As anyone who is closely following the space tech sector in India would know, space is now closer than ever. In this episode, your host Akshay Dutt is talking with Sanjay Nekkanti and Chaitanya Dora Surapureddy, the co-founders of Dhruva Space, which is in the business of making space accessible to businesses. Sanjay is literally a rocket scientist who became a founder, and Chaitanya is the data scientist who joined hands with Sanjay. In this conversation, they talk about all things space, including low Earth orbit satellites, why satellites are a big business, and how they are building the full stack for businesses to take advantage of satellite technology. Stay tuned and follow the Founder Thesis podcast on any audio streaming app to learn about conquering new horizons and making dreams come true.
My dad used to work for the military engineering services. So after my birth, I was based in Hyderabad. So I did all my schooling here. And my seventh standard was a little unusual. I was in this city called Bhuj, and Bhuj is an Air Force station. So every day after school, there used to be a point where I used to go and see the fighter jets take off. I was actually preparing for IIT JEE. I didn't get into any of the IITs, so I had a couple of options. One was Manipal, VIP, and SRM. I picked SRM. So I picked the stream of electronics and telecommunication. And I used to have this unusual hobby called ham radio, wherein you have a license that is issued by Government of India, and you could use it to talk to different people around the world. In a ham radio, essentially what you have is a radio set. And this radio set can communicate in different frequencies. So you have different frequency bands, especially for long distance communications. You use this band called HF, which is the high frequency. And in HF, you can talk to people as far as even Russia. So I was this ham radio operator in college, and one fine day there was a scientist from ISRO who had reached out to our university and said we as students could actually build and launch our own satellite. Our college management they were like very excited. They felt that if this is really possible, then they really want their students to build and launch the satellite. I thought that this would probably not kick off, but a couple of months down the line, actually our college decided to fund a student satellite project. And the student satellite project comprised of students from different engineering departments coming together to build the satellite. People from computer science would write the code. People from mechanical engineering department would build the structure. The EEE department would do the power systems for the satellite, so on and so forth. And the telecommunications department is responsible for the communications with the satellite. So our department was like, hey, we have this guy who's a ham radio operator who's been here and done similar work in the past. So they suggested my name to be a part of that group. And that's how I got into the space of actually building satellites. So as part of the team, I was handling the communication system and the ground station part, which is operations of the satellite. And we were a team of about 30 to 40 students who were given the responsibility to build the satellite. Launching responsibility was in the hands of ISRO because we were not building the rocket. And it so happened that we were challenged. So ISRO said, look, guys, you have to build and launch your satellite in less than 24 months. Of signing the MOU. And if you do not complete it within the stipulated time, then, we are sorry, you're not going to fly. So we named our first satellite SRM Sat because it was the university, SRM University, who was funding the project. And it was SRM Sat Mission, India's first student nanosatellite. Within a period of about 24 months, we had to develop the full satellite. And while building this, we also had to do our coursework. The first step to getting something done as soon as possible would be to buy different parts and then put them all together. And we did that exercise. So when we did that exercise of finding different parts to put it all together, the cost was very, very high. So we were talking in terms of tens of crores. Now, the budget that was allocated was just a few crores. So in order to achieve all of this in such a short period of time, it was quite challenging for us because now we had to develop everything ourselves to keep the costs low. But what was very exciting is that now the challenge is even bigger. You have to do it all yourself, build it all yourself. But the best part was we were getting guidance from the stalwarts of the Indian Space Research Organization. I still remember this one particular incident. We needed to test our satellite. And for testing, you need to put it on a vibration bench, which can be very expensive. And there were also several other tests that we had to perform, and they were all like very expensive to procure. So we went to our director of research back then and told him, "Sir, you expect us to build this, but how can we do it? We don't have the resources, etc." And this person is a former ISRO scientist. So he goes on to say, "Guys, have you seen that picture of ISRO carrying the satellite on a bullock cart?"
Yeah, I do recall. I have. Yeah.
You just have to find innovative means to actually solve your problem. And when you look at a problem and you think to solve that problem the way how everybody else has solved it, that's one approach. But you could always take a very different approach to solving problems. So within a short period of about 24 months, we actually ended up building almost all the subsystems of the satellite. And we had also realized it within a shoestring budget. And while doing all of this, one thought that was running in my mind was, we're a country with 1 billion people, but there's not a single private company in the country that is building these solutions for the global market. Because when we wanted to build the satellite and we went out into the market to find the cost of different systems, putting all together, it was running into tens of crores. But now when we built it all ourselves, it was within a small budget. And Indian space program is well known for that, frugal innovation. And that was really the motivation for me towards thinking about starting a company to provide space technology solutions for the global market from India. I immediately went and pitched this idea to my fellow team members in the project. And I said, "Hey, guys, looks like a great opportunity. We should do it." But everybody in the satellite team had job offer already in place. And the Startup India movement and the thrust from the government to support entrepreneurship really came up in this decade. But in the last decade, in the era of 2000 to 2010, it was not really that famous. So nobody was actually willing to take that risk of taking an entrepreneurial path, that too in a domain which is not very famous or not very common. But I still did push people saying they should do it. And one of them said, "What is the guarantee that if you do this, somebody is really going to buy?" And if you're talking about building in India and selling globally, you really need validation that if you build in India, somebody in the Western world is really going to buy it. So what we had done back then was I thought it was fair enough, and we really had to do some sort of validation. So what we did was we picked one of the sensors that we had used in the satellite. The same sensor also has some applications on ground, and we had actually produced them in a small quantity and put it up on eBay for people to buy and use them. And it actually worked. There were a few people who actually bought some of these sensors. So at least for me, the validation was there that if you have an idea, if you have a product, and if you're really trying to solve a problem, then there's a strong business case that can be explored. My backup option was that I would go and do my master's in the same field. We built satellites in India. I wanted to see how satellites were built in the Western world. So I got accepted to this program called Erasmus Mundus Space Master. My class size was about 44 people coming in from 27 different countries. We learned different domains of space technology in different countries. So I spent about 6 months in Germany, where we worked on small satellites. And it was very interesting because in India, I had built a nano satellite, which was a 10 kg class satellite. Nano satellite would be the size of a desktop printer. And in Germany, we were working on satellites that are the size of a tiffin box.
So you're saying that nano is bigger than small satellites?
Yeah, nano is bigger than satellites that I learned working on it.
Pico satellite. Okay. So satellites don't have propulsion in it, do they? Or
Few satellites do have.
okay. So satellite is essentially a collection of telecommunication instruments which are and sensors. Like it is sensing some data and then it is communicating that data back to Earth.
It has many things. It has the satellite structure. It has your satellite solar panels, which generate power for the satellite. It has a power distribution unit and a storage unit, which charges the battery, supplies it to different parts. Then, like a computer, there is also an onboard computer for a satellite whose job is to do things intelligently in terms of commanding, controlling, etc. Then you have a system called attitude determination and control system, which essentially determines the orientation of the satellite in space. And that is a combination of several sensors and actuators. And propulsion is one part of it. Like you use sensors like sun sensors, earth sensors, star sensors. You use global positioning systems and you run different orbital algorithms. It's a fairly complex system. And you use these torquer coils and action wheels, etc., as different actuators to stabilize the satellite. After all of this comes your communication system, whose job is to send health data of the satellite, receive signals from the ground, and give that information to the OBC, etc. And then you have the payload. Payload is essentially what is the main task of the satellite. So if you're a weather satellite, then the instrument becomes part of the payload. If it's imaging satellite, then camera is the payload, so on and so forth. And space systems engineering entails putting all of these together.
What is a torquer coil?
Torquer coil it's like coil wounded around a metal bar that is needed for producing electric and magnetic fields to ensure that it generates a certain torque in a particular direction to stabilize the satellite. And this German university had already built and launched about 3 satellites by then. And after that, I spent the next 1 year in Sweden at the Swedish Institute of Space Physics. It's in a place called Kiruna, and it's inside the Arctic Circle. And Swedish Institute of Space Physics is really well known for building instruments that go on to a lot of interplanetary missions. So it was really exciting to mix with different cultures, learn different parts of the space tech value chain, work on different types of missions like satellites in Germany, instruments in Sweden. I think I also had the opportunity to work on instrument and send it up the stratosphere about 35 kilometers using a high altitude balloon. And then for my master thesis, I had 2 options. The first one was doing a project at NASA Ames Research Center on a mission to Titan. So just randomly one day, I just wrote to a professor at NASA Ames and said, I'm really passionate about this particular subject and this is my past experience and I would really like to get into doing some project under your guidance. And this professor, he had actually worked on missions to Mars. And within 12 hours, I actually got a response saying, your profile looks interesting and there is a space systems engineering project that you could potentially work on. And we had multiple calls over the next few days. And, it was a clear fit for me to go and work on a mission there. But yeah, one of the biggest challenges was to get my visa within a stipulated time to go there and do it, which I couldn't get. So my backup option, if NASA didn't work out, was to go to Singapore, work on the first few satellites that were being built at Singapore. So I worked as a research assistant at Nanyang Technological University, and I played an important role in assessment and qualification of the first few satellites built there.
How did this lead to Dhruva?
Yeah, as part of my master's program, I was still having that thing in mind that I should go back to India after my master's and start a space tech company. So I spoke to my peer group and said, hey, we should do this. There's a big market, try to convince them. And I was able to convince one of them to come back to India along with me to start Dhruva Space. So yeah, finished my master's in 2012, came back to India and started Dhruva Space. So the initial founding team of Dhruva Space is very different from the current founding team of Dhruva Space. And that's what we will learn from very shortly. So when we started the company in 2012, we were mostly focused on supporting student satellite projects that were happening in the country. And I would say we were also closely working with the Indian Institute of Astrophysics with Professor Jayant Murthy. His team was working on high altitude ballooning missions. So we supported some of these missions in the first phase between 2012 and 2015. It was very difficult for us to find customers within the country and also outside of the country, because in the space sector, it was extremely important that there was already some heritage, in the sense we should have already built and launched something, so on and so forth. And access to venture capital was also very tough. When you speak to investors, it's also the same thing. Have you done this? If so, has ISRO validated it? Have you launched it into space? Do you have paying customers with you? How can we be so sure that this model is going to work, so on and so forth? So in the first part of the Dhruva journey between 2012 and 2015, it was an exploratory phase and it was very, very tough. But we got a very good hang of what customers want, what investors want, what partners want, and how do you build a great team. So we paused our operations in 2015 and I started consulting.
Till 2015, you were running as a technology consulting partner, basically. That's what you would have been doing. Or were you trying to do a product, like actually build a satellite as a product?
So I would say it was a mix. Largely, it was consulting, but we also conceptualized a satellite program for ANSAT India. We'd worked through the details of it. We had the designs ready, blueprints ready, but we couldn't really do much because for us to do that, we needed access to capital. So around 2015, we took a step back. We paused the operations. My co-founding team back then also started consulting and they also moved out of the country. Narayan Prasad, who is the founder of Sat Search, today was also the first co-founder of Dhruva Space. Mr. Abhishek Raju, who is the co-founder of Shore, was also a co-founding partner at Dhruva Space. And so what I did was I continued to stay in the country. Narayan moved to Germany and Netherlands. After that, moved to Switzerland. I stayed back in India. I was consulting for various companies. I was consulting for antenna manufacturing company. I was consulting for Thibault, where I found my current co-founding team. And I was also consulting for a company called Exceed Space, which is now called Satellize. But yeah, the real mix of great team of engineers, great team of founders came through Thibault. And today, that is the real foundation block of Dhruva 2.0.
And so Thibault is where Chaitanya's story comes in.
Yes.
Okay. So Chaitanya, tell me about your journey of starting up Thibault.
If you don't mind, for that, I need to get a mental image out of my head. So when Sanjay was telling us the bullock cart story, saying that he said this thing. So now my doubt is, instead of vibration table, did you put the satellite on a bullock cart and run it through a very rocky road?
For the vibration bench test.
Yes. But anyway, coming back to the question at hand, yeah, we studied together in 11th and 12th, me, Sanjay and Abhay. Then post that, I, Abhay and Krishna, the other two co-founders, we studied together in BITS Pilani Goa campus. I decided early on that I want to move more onto the business side of things. So post-graduation, I did my master's in management from EM Lyon in France. Came back, worked with KPMG in management consulting, where I was advising the government of AP. And then went on to work with an NGO called Safe Water Network, where I was leading their IoT team. And about a year into working there, I and Krishna started up Thibault. So they're like, do you want to come join? I was like, oh, hell yeah. Working with a couple of your friends. And of course, I always wanted to be an entrepreneur. Leading the business side of things, I jumped at this idea, and that's when Thibault started. So we started off in 2017. As a company. And we initially wanted to work more as a design house. So not really an out and out startup, because we realized that the IoT products that we've chosen to build, getting the market access to these is pretty tricky. So we were trying to work with established companies who are already in that field. We build the design, we have the IP, we work with them to take the product to the market, and we take royalties out of the whole deal. So that's where it started off. And Sanjay was having already had an out and out career in entrepreneurship. He was advising us. We developed a couple of interesting products. One, a ultrasonic water meter, the first one to be officially approved by FCRI in the country with an IoT angle to it, and also water quality sensors for shrimp farming, and a complete suite that we built around that area. While we were doing this, Sanjay comes up to us and he was like, guys, I think it's time to revive Dhruva Space. Why don't you join me in doing that? And he's like, you guys will make the perfect fit. You have so-and-so competency, I have so-and-so competency. It's really can take off. And there was also good traction from the investors around this period where the space was kicking off. My take to that was, dude, I have no clue what space is. I'm fascinated by space. I dreamed of space as a kid. It's brilliant, but I haven't done engineering in a while, science in a while. And now it's rocket science or satellite science in our case. He's like, okay, why don't you do this small exercise? There was a call by European Space Agency's Business Incubation Center, where for incubation, they said, you guys can come incubate. There was a proposal that we need to write. Like, why don't you just write it by yourself? I'm like, sure. So I wrote with a little bit of help from Abhay, and Sanjay's like, I'm completely staying out of it. You wrote yourself so that you get that confidence. So I got some help from Abhay and Krishna, wrote most of it by myself. Then we were invited to come pitch in Austria. So we are like, okay, still in initial stages of our entrepreneurship journey, didn't want the whole team to travel. So sent Abhay. He went, pitched it. Literally, it was a 2-day trip. I was like, I felt it made sense to stay for a bit, travel around, but he's like, no, I'm coming back. Went, pitched, was back exactly 2 days later, and they invite us and say, please come incubate. I was like, okay, that gave me the confidence. And I think I'm like, okay, fine. I think, yes, we can bring in a lot of capability, even if I have not built a satellite or worked on this thing. So that capability anyway Sanjay has. Again, working with friends was the most exciting part for me.
Essentially, Thibault was like just the co-founders. Like it was not like a company which had a lot of employees and all of that. So hence the co-founders moved into Dhruva Space. Like that's how that like you joined forces, or
we had a team of around 12 to 14 in Thibault itself, but we did carry on the whole team because even the team was built, especially on the engineering side and the product development, they were well this thing trained.
And Thibault was in the space of IoT, like that was the IoT and IoT-based analytics, like that was the core area.
Yeah, exactly. It was IoT and mostly on the hardware side, a bit on the software.
So when did you decide to join hands and collectively become Dhruva?
I'd say early 2019, we decided to join hands and go and restart Dhruva.
Let me ask Sanjay here now. Like Sanjay, so when you restarted Dhruva with the Thibault team, what was the thesis? Like, what did you want to do?
It was very clear that we wanted to be a product company, but we also had the sense that services is something that we might do in the future. And that's been a path also at Thibault that we were conceptualizing. So we are a product company that can in future do services leveraging the product.
And what is the product that Dhruva was pitching? Like you went to Mumbai Angels to pitch for funds. What did you pitch there? What was the product?
Yeah. So what we did was we actually broke down what was the biggest challenge in the space industry. So this is what we looked at. Constellations of satellites was becoming a very common term. And when you say constellations of satellites, you're talking about launching hundreds of satellites in one go.
This is what Bharti is doing for satellite internet, or Elon Musk is also doing Starlink for basically satellite internet. This satellite internet coverage, you need a constellation of satellites to ensure 24-hour coverage. So that is the concept.
Yes, that's correct. So everybody was talking about constellations, right? Guys who are building constellations, what is driving their business? Their business driver is not the space asset. The business driver is the data coming out of the space asset.
Yeah, the Bharti Hotel is selling like a Mbps per Mbps. That's what their revenue would be. Like how many Mbps of, or like what is the GB of data consumed?
Yeah. That's correct. And there are other companies that are building weather satellites. Somebody is doing imaging satellites, etc. And now if you look at the landscape, US government has roughly about 1500 space assets. China has roughly about 500 space assets. India has launched about 80 of its own satellites in the last 4 to 5 decades.
So this number is the government or overall US, like government, private, both 1,500 space assets?
Only government. OneWeb has filed for launching more than 5,000 satellites. Starlink has filed for launching more than tens of thousands of satellites. So now if you can understand the scale, you're talking about launching tens of thousands of satellites. Like there are at least 100 countries in the world today that have never launched anything to space. And countries which are also known as spacefaring nations, the number of satellites have been smaller. So where I'm getting at is the problem that we are really trying to solve is to break that barrier. There needs to be a fundamental change in how you build satellites, how you launch them, and how you operate them. And that's the problem that Dhruva has picked and is building. So we are building platforms that enable organizations to launch their own constellations.
So essentially, it's like a plug and play approach to launching a satellite. You don't need to, like what took you 24 months at SRM to launch that one satellite. Today, somebody could just log on to the Dhruva platform and in a pretty short time, they could have a satellite scheduled for launch. That's the vision.
Yes, that's the vision.
Got it. Okay.
So we broke it down into simpler parts. The integral part of any space mission are 3 pillars. The first one is your space pillar, which is building of the satellite itself. The second is the launch pillar, which is launching and putting the satellite in the orbit. The third is the operations or the ground pillar, which is used for commanding and controlling the satellite. So we are a product company where we build products in all these segments to enable the full constellation. So on the space segment or on the space pillar, we build satellites that are application agnostic. So for example, somebody might want to do a satellite for only communication, then we have a different platform. Somebody wants to do imaging, then they use a different platform. Somebody wants to do very sophisticated missions, then for that we have a different. What we don't do on the satellite is we don't build the payloads.
So payloads are like, because there is a lot of diversity in payloads, every company will have their own design for a payload, so that they will like just plug into the satellite. But the everything else except for the payload, you are like a plug and play service.
Correct. This is what we do on the space segment. On the launch segment, see, we would want to launch satellites at a faster pace, right? Now, if we could look at the possibilities of building our own launch vehicle, but instead what we thought is that's a very, very difficult problem to solve. And none of us have that experience in that domain. So we picked the interface problem. Our satellites should have the possibility to go on to any rocket. So we started building the interfaces that would enable our satellites to go on to any rocket. So we built those deployers. Then you build it, you launch the satellite. Now you need the operations piece to operate the satellite. So we have a product that you can use to operate satellites, existing as well as the ones that will come up in the future.
So how do rockets deploy satellites? I thought that it would be like a cavity in a rocket where all those satellite boxes are placed and it just ejects those. It's not like that, is it?
Yes, it does, but those cavities are not, those boxes are made by very few people around the world and they can be very, very expensive. So we build those boxes and cavities that can go on to any rocket.
So tell me the evolution. So you had this ambitious plan to become a platform offering all 3 pillars: space, launch, and ground ops. Tell me the evolution, how you started. And
yeah, so we went the same way how we would go ahead and build our first satellite. So before you launch a satellite, you apply for your frequency, you first set up your ground station. Then you would go and also figure out the launch side of things. like when tentatively you're launching the satellite and pay in advance and book that launch slot, and then get to the space segment wherein you actually start building the satellite. So one of our strategies was that we need to have a paying customer before we build a product. And that was extremely important for us. Oftentimes, we as engineers fall into that trap of building a very rosy product, but which people may not actually need. So, what we started off was we started talking to prospective customers who were interested in having their own space program. And we had already architected the bare bones of the product. And we went ahead and pitched it to a few people. And one of the forward looking educational institutions based in both Andhra Pradesh and Telangana, they were very excited and they moved forward. And this is B.V. Raju Institute of Technology.
There's like an engineering college.
Yes, an engineering college. So they wanted their students to build and launch a satellite, and they wanted a long-term roadmap. That they didn't want something one-off. They wanted a 5-year roadmap, a 7-year, 10-year roadmap on how the program could evolve and how that would have an impact on the students on a career path, and also in terms of, in general, working on high-tech products and projects. So with that thesis, we had acquired our first customer, which is VRIT, for building the ground segment. Now on the launch segment, there was an announcement of opportunity from ISRO where they said there was a global call and they asked organizations to submit proposals that would be, and they would pick proposals for a free launch that are of national importance or are of societal benefit. And we believe that there was a clear gap for production of these deployers in India. So we had submitted a proposal for them to accept our strategy on building these deployers and testing them in orbit.
So a deployer is a box that goes inside the rocket and the satellites are loaded inside that deployer and it throws them out or something like that.
Correct. And our proposal got accepted. So we have the ground segment, we have the launch segment. Now comes the space segment. On the space segment, we were already architecting a platform. All the blueprints were ready. We had certain ideas on what the platform should be doing, so on and so forth. And now that we had 2 pieces already solved, we were looking for a third piece so that we could offer a full stack solution. So we started talking to multiple customers and we actually ended up finding the customer to whom we could do a full stack, which is enable them to build a satellite. We will be launching the satellite for them and establishing a ground station. And we went one step further where we also found repeatability of customers.
Which customer was this that you signed up?
It's an academic institution in Odisha.
So again, the goal is education. Like it would have an engineering course and the engineering students would learn to build satellites and work on the data from them and stuff like that.
Actually, no. So as part of the ecosystem building exercise, we wanted our programs to have a very strong industry academia collaboration. So most of these we're doing about 3 programs now and with academia, and all these 3 programs are faculty led programs. So it's not like a student satellite project, but it's a faculty satellite project.
Got it. So it allows that college to go out and get work from corporates. Essentially, they, as knowledge partners for corporates, can run some of these things.
Yes, absolutely. So think of it this way. So today we are training the faculty in building and launching the satellite. Tomorrow, we would be in a position to actually give the faculty an R&D project to build and develop it and give it back to us.
Okay, got it.
So this is one market vertical. Then the other market vertical that we have is government and defense. And the third vertical that we have is enterprise customers. So on the government vertical also, we have a customer. This is a defense client for whom we are building space-grade solar panels for their satellite project. And on the enterprise side, we're having conversations with overseas customers to meet some of their requirements.
And are these funded by customers or did you raise funds to fund these projects?
So all in all, we are executing orders worth $3.5 million. And for all these projects, although the customer had given us a small advance, we had to raise capital to execute these orders.
Okay. And tell me about that fundraise journey. Did that pitch to Mumbai Angels, did it work out? Did it convert?
Yeah. So when we raised our first round of capital, we had met about 160 investors in the country. And I'm really thankful to the Mumbai Angels team in actually enabling us quite a bit. See, most of the investors that we met felt that we were raising too less capital with a very broad goal and it wouldn't be sufficient for us. But out of the 160, there were I would say a small portion of them came on board to support our journey. So we raised about 4.5 crores through Mumbai Angels and Lead Angels. This was our first round in November of 2019. After that, we raised our next round last year of about $3 million from the Indian Angel Network Fund and Blue Ashwa Capital.
So when you say you have $3 million worth of orders to execute, so how do you charge? Is it that, say, somebody like your first client was an engineering college that wanted a ground operations center to be built? So is it a subscription or is it a one-time fees, or what is the economics of it?
As I mentioned, we are a product company. So we have a product pricing. Customers pay for the product. Some of these have a lead time for delivery. Usually we have customers also pay in advance before the full delivery of the product.
Give me an idea. How much would it cost to set up a ground operations center, or how much would it cost to launch a satellite?
Yeah, we offer training to organizations to build, launch, and operate their satellite starting at about 2 crores.
And this doesn't include hardware, like the actual because
this includes hardware.
Okay, it includes hardware. Okay. And starting at 2 crores, the organization could have a satellite in space which is sending the data back, and they are able to work on that data.
Correct. But this would be only a communication satellite. If you're looking imaging satellites, etc., the price can go up to $2 to $3 million, depending on what size of satellite, which orbit you want to launch your satellite, how many ground stations you need, so on and so forth.
Help me understand some of these decisions. Which orbit does a satellite go into? What is the criteria for that decision? And whether you need one ground station or more than one ground station, what is the criteria for that decision?
Okay. So most of the satellites that we build at Dhruva are all going into the low Earth orbit. And typically a satellite in low Earth orbit will go around the Earth 14 times in a day. It's capturing a lot of data, right? Now, if you want to bring down all of this data, then you will have to have ground stations distributed around the world. But if you're interested in data only, let's say over India, then maybe a few ground stations in India or one ground station in India would suffice. This is with respect to the ground segment. Now, with respect to the orbit, see, the orbit will come into question largely when you want to launch more than a few satellites in one go. Okay? Because think of it this way, if you launch more of them, you'll have the flexibility to get coverage over a region of interest with less number of satellites or more frequent visits, so on and so forth.
Typically, satellites are launched on low Earth orbit only, like that's the ideal orbit, or what determines that whether it's a low Earth orbit, or what is the opposite of? Is it a high Earth orbit, or what do you?
Yeah. So when I say orbit selection, I'm talking specifically in terms of inclinations. The small satellites are usually launched into the low Earth orbit, typically between 400 and 1200 kilometers. And what defines your orbit is also the primary satellite, because your small satellites typically weigh anywhere between 1 kilogram and 50 kilograms, or less than 300 kilograms. If you're talking like launching on a launch vehicle like PSLV carries up to 1800 kilograms. So now if you have to put only one satellite on a rocket that is carrying 800 kilograms, you cannot demand where you want to be put in orbit. So you will have to take what you get.
But you said that these satellites have a propulsion system on board, so you are able to finalize like what is the height at which, what is the altitude at which they should be, what path they should be taking through the propulsion system.
Actually, it's a very good question. Not all satellites have propulsion systems, Akshay. There are few satellites that specifically need propulsion system. There are few satellites that don't need propulsion system. And usually customers are okay to go to a location where the primary satellite is going, because largely the primary satellite will also have a very decent coverage around the world.
And what determines whether a satellite will have a propulsion system or not?
Okay. One, as you pointed out, if they want to do some sort of maneuvers, moving an orbit up and down, then the propulsion system is needed. If you want to do orbit raising specifically, moving from one orbit to the other orbit, then the propulsion system is needed. Today, one of the upcoming areas where people are also using propulsion system is for deorbiting and to avoid collision risk. Okay, which when deorbiting is after your satellite life is over, you will try to bring down the altitude of the spacecraft so that it can re-enter the Earth's atmosphere and burn out during re-entry.
And why would a satellite want to change its orbit? Like you said, you need propulsion if they want to raise the orbit. Why would a satellite want to do that?
Okay, that depends on the application. Some missions, let's say you're doing formation flying, wherein 3 satellites have to come close to each other to study a particular area. In that case, without a propulsion system, doing a formation flying will be extremely difficult.
This would be like for taking photographs or something like that.
Comms also, let's say you want to triangulate a signal on the ground, then also you would need to do formation flying, etc.
I want to talk a bit on use cases of satellite from a business perspective, and maybe you could throw some light that what are the business opportunities through satellites? Like,
first one is communications. Second one is Earth observation, which is you're studying your planet using imagery obtained from the satellites. It could have impact on how cities are designed, how much agriculture produce is happening, etc. Third could be in navigation. So there's something called as PNT, positional navigation and timing. These are very important for your civil engineering construction applications, for your navigational applications. So if the future of vehicles is autonomous, satellites will play a very important aspect in autonomous navigation. In addition to this, you have space weather and you also have earth weather. Okay. And then you have general research and interplanetary missions. And then one of the other fields which is really upcoming is pharma and biotech.
okay, but what is the use case for a pharma company to have a satellite?
Okay. Usually, if you have to get a drug out into the market, it takes anywhere between 7 to 10 years or probably beyond that. So, one of the very important aspects in this phase of drug development and drug discovery is crystal growth, where different molecules are put together and crystals are grown and their characteristics are studied, right? Now, when you're doing this on Earth, you're actually trying to put it inside a small centrifuge that is trying to create some artificial gravity for those crystals to grow.
So the crystals grow faster in zero gravity. That's what you're saying.
Yes. And they're very clear. So a lot of those can be used for drug discovery and drug discovery experiments. A lot of these are also being used for new cosmetics formulations, so on and so forth. So this is an upcoming field.
How would they be grown? Like every time a pharma company wants to grow a crystal, they would launch a satellite with those raw ingredients in it, and the crystals would grow, and then there would be some onboard microscope which would allow them to study it, or would they then bring it back to Earth and then study it? Like,
very good question. One of the capabilities of Dhruva is also that we can take things to space and bring them back to Earth. So we have a partner in the US through whom we could take payloads to the International Space Station, run an experiment there, and also bring them back to Earth. We're also trying to work with ISRO, where we could in the future also do something similar here in India.
These use cases for which you feel that countries would launch satellites, a lot of these are like off-the-shelf plug-and-play services like communication, navigation, or even I'm sure for Earth observation. As a layperson, I know Google Earth does it, but I'm sure there would be more business like pro tools than just the Google Earth for space observation. So like, why would countries want to launch satellites for all of this?
A lot of data that we use today in our common life is data for which somebody is paying somewhere and it doesn't get noticed in a big way. And also your data may not be extremely accurate. So you must have, if you've used an iPhone and you put that thing on Find My iPhone, and if you go and try to really find the exact location, especially in India, you will never be able to track where exactly is the phone. It will only give you an approximation.
Just to add to that, the GPS boards that we get are built in with a certain offset, wherein they are actively making your product showcasing little mistake in your final location. So this is because the government that has built your setup, they do not want you to use this for highly accurate systems where you can probably abuse it. So they don't want to give that to your foreign government. Similarly, you look at Ukraine. So during the war, Russia, one of the first things they did was destroy most of the comms, the internet, etc. So there was all this thing where they were taking help from Elon Musk on Starlink. So there are a lot of cases where you might not be able to rely on existing infrastructure, be it the government infrastructure, foreign government, or a foreign company. Same thing comes with imaging. So you're at a war or you're in a critical this thing. Again, you are dependent on a foreign company to give you the images. So there are quite a few of these things where it is necessary that you have your own.
Okay, got it. Is there a way for governments to stop satellites from prying into sensitive areas? Can India just put up a satellite and look at China's nuclear facilities, for example?
There are very interesting ways in which you could misguide the satellite also. For example, the satellites might detect a few colors. You can have a camouflage on the ground that doesn't show off those colors. Or when you look from space, objects look in a particular way. So you could actually have dummy objects trying to look like real objects. And of course, you could also jam signals if you don't want certain signals to come, etc.
How would you jam a signal? Like you'd shoot a radio beam at that satellite to jam its outgoing signal, something like that.
Yeah, jammer. So going into the technicalities of the jammer, you can produce higher power to saturate the other radio. It's not very different from how you jam signals on the ground. It's the same principles.
My last question to you, what's the road ahead for Dhruva? Say by 2025, where do you see yourself?
We've come a long way since we started the company in 2012. We're working very hard towards being a full stack service provider for use cases in India, for customers in India and also outside of India. We believe today we have the potential to look towards owning our own constellation of satellites to offer specific services. I believe between 2025 and 2027, we might be heading towards having our own sets of satellites in orbit, trying to power solutions on the ground.
Wow. Which would probably need a lot more fundraise also to launch a constellation. How much money would that need if you want to launch a constellation of satellites? Like $100 million or something?
It really boils down to the application. It depends on what type of application you're targeting. See, using our P-dot series of satellites, we could create a network of satellites in the low Earth orbit to provide low data rate communications. And for us to put about 50 to 100 satellites, it would cost us anywhere between $10 to $20 million.
What is a low data rate communication? And low data rate as opposed to what? It's basically like bandwidth is low. Is that what it means?
Yeah, this would be well suited for IoT applications, but may not be great for streaming 4K data.
You can also probably use it for messaging in extreme remote areas. especially for emergency situations, etc.
So do you currently have customers outside of India, or is your revenue largely from India?
All our current booked revenues are from India. We are closer to signing something with customers from outside of India.
Do you have competitors in India, or all your competitors are global? Are there other companies in India which are offering this full stack solution to launch satellites?
I would say within India, we are largely complementary within the ecosystem. I've not come across a player who is a full stack provider from India yet. But yeah, we are largely complementary within the Indian ecosystem.
And globally, there are players who are doing what you're doing. Like,
when it comes to competition from outside of India, there are definitely people who've raised more capital, who've already been there, done that, etc. Our thesis is very simple, Akshay. We are based in India. India has launched about 80 satellites so far. We believe these numbers are going to increase. We would like to be a very strong regional player. We want to be in the top 3 space companies in the country, and at the same time provide our solutions in the global market. Our competitors have definitely raised a lot of capital and they are way ahead of us, also because they come from very different markets.
but I guess your strength would be frugal innovation. Like, probably the cost at which you would be able to do it would be much lower than what a global company would charge.
So our key differentiator would be being faster, reliable, and providing an economical solution for the global markets.
So, Sanjay, we recorded, and this is just a note for the audience that what you heard so far was recorded in May of 2022. And Sanjay is joining us here for some updates since then. So, Sanjay, please share with our listeners about some exciting updates that have happened.
Yeah, I think I would say less than a year, and we've gone to space twice, in the process of going to space the third time. So I think the last 1 year has been like pretty crazy, pretty busy. And most importantly, we've been doing a lot of things in space successfully.
So, what do you mean gone to space? Just like paint a picture of that.
Sure. So, maybe just giving a quick refresher to the audience. Dhruva Space is a full stack space technology company. We work on the space segment where we build satellites. We work on the launch segment where we don't necessarily build the rocket, but we build the interface between the spacecraft and the rocket, which enables our spacecrafts to sit on any rocket in the world. And then the ground segment where we build these communication terminals for operating satellites once they're in orbit. So in the last 1 year, we've happy to bring your attention that we've completed the full loop. So we've built the satellite, we've launched the satellite, we've operated the satellites. And, as of 1st February, 2 of our satellites, Thibault 1 and Thibault 2, have gone around the Earth more than 1,000 times, which is crazy.
So this would have been like an Indian rocket company which launched it, or like where did you launch?
Yeah, so let me actually break it down into pieces, and I'll just tell you about going to space. So our first launch happened in June of 2022, and in this particular launch, what we did was we tested our interface between the spacecraft and the rocket. So we didn't deploy anything into space, but that interface, stuck onto the Indian Polar Satellite Launch Vehicle. And, once it went to space, we tested its performance, whether the door is opening properly, whether it is responding to the commands from the rocket properly, and so on and so forth. And in November 2022, what we did was we used the same interface to actually deploy 2 satellites, 1 and Thibault 2, which are based on the P-dot platform, P-dot satellite platform of Dhruva Space. And these missions are all authorized by the new regulatory body in India called InSpace. So until 2020 in India, there were no, the regulatory regime has been evolving. So in the year 2020, InSpace was formed. And InSpace is the regulatory body which will govern all the private space activities in the country. So, and, technically they were the ones who authorized us to do both of these missions.
So it's like a try for telecom, so similar kind of a body for the space tech industry.
Spot on.
And what do these 2 satellites do? What's their commercial use?
Okay, so these two are technology demonstration satellites which do not have a commercial use case, but they are suited for the amateur radio applications where ham radio operators from India could actually utilize these satellites to operate them for communication applications. What did we actually test? I would say, the entire P-dot spacecraft platform of Dhruva Space. So essentially, every part of the spacecraft, meaning the satellite structure, the satellite solar panels, the communication modules, along with an antenna deployment mechanism, the attitude determination control system of the spacecraft, all have been indigenously developed in Hyderabad. Essentially, most of it is not most of it. In fact, every part of the spacecraft has been designed, manufactured in India and sent to space for the first time. And all of them have performed nominally, which I believe is a significant achievement because it's definitely rocket science.
Yeah. What do you mean perform nominally? What does that term nominally mean?
Performed as per the design. So all of the systems are performing exactly the way they are supposed to perform without any abnormalities.
So this is your proof of concept up in the sky, basically.
Absolutely.
Right. And how has this helped you in terms of being able to win business? Are there some deals in the pipeline?
Well, to be very honest, Akshay, for the P-Dot platform, we already have customers even before the tech demo missions. But, being a very customer-centric company, it was extremely important for us that, we wanted to give our customers the best experience. So we wanted to do this trial mission before the customer demos. So the customer demonstrations will happen this year. In terms of how has been the market reaction to what we've done, the market reaction has been extremely positive. And I truly believe that the small milestone of our company is having a significant impact, not just for our company, but for the whole country, right? A lot of foreign players who have leveraged the Indian rocket for launching their satellites are now looking to the Indian industries on how they can support their global ambitions. So I would say, it's a small step, but a great milestone for the entire private space tech ecosystem in India.
What are the kind of customers and for what kind of use cases are you like focusing on? Because I mean, obviously the market is pretty huge, but you would probably want to have some specialization initially to go after a certain type of customer who wants to launch a certain type of satellite.
Sure. So, Akshay, what is missing today, especially from an Indian private space tech ecosystem scenario, is you don't have like a prime contractor in India, right? In the US, you have, Boeing, Lockheed Martin. In Europe, you have Thales Alenia, you have Airbus, right? But in India, there's no such framework that exists. And if you go down to the fundamentals of what Dhruva has been building, is we've been building the foundation for becoming a prime contractor in India. So from a customer perspective, our customers largely come from three segments. The first segment is government and defense. The second segment is enterprise customers. And the third is academia or research customers. And because of our full stack approach, which is, having the ability to build satellites and satellite systems on the launch vehicle, provide an interface enabling the satellite to go onto any launch vehicle in the world. And then, the ground segments to operate these satellites. Our customer base has been quite wide. So we are not focused on any specific application, but we are focused on serving the entire suite of the space tech ecosystem. So, I mean, we've been getting customer interest from across the spectrum. In fact, we're already delivering certain systems across all the segments, enterprise, government, defense, as well as academia customers.
how many satellites a year would you be launching once you are at profitability stage? Like, what would that look like? Just paint a picture for me. Like, at a profitable stage, you would be doing X launches a year, or working with deploying X number of satellites, or these number of satellites in orbit. And what is the timeline for that like?
Sure. So Akshay, I think I'll just go back to the thing that we're focused on being a very strong customer centric company, and today the market is more. From the 1960s until 2020, there were probably about 15,000 satellites launched. It is estimated that more than 100,000 satellites will be launched in the coming decade or so. So there is definitely a very huge need for satellites to be produced rapidly, launched rapidly, and have the ability to operate these satellites in a very simple fashion. So to answer your question, we don't have a quick number in mind to say that this year we want to launch like 1,000 satellites, so on and so forth. The foundation that we have built is to ensure that at least the P dot platform on which thigh bolts are made, we could produce at least a few of them every single day. And for the P30, which is a slightly larger platform, produce a few per week. And then the large platform, which is a P90, maybe produce a few every quarter. So that's the goal that we are targeting. And considering that we've been a very capital efficient company, we've raised the smallest amount of capital in the space tech ecosystem in India. We already have a few satellites in orbit. Now we are looking at that growth capital that will define, how these will pan out in the next few years.
Sounds like it would need a heavy amount of investment in manufacturing also, if you're producing a few small satellites every day. So would you have like a factory, or how do these satellites get built?
So the short answer is that yes, we need a very large manufacturing capability and newer ways of manufacturing things to hit that rapid scale. And our approach is the following. There are more than 300 to 400 MSMEs in India that have been acting as the backbone for the Indian space program for the last few decades. So, we're already leveraging this ecosystem to be very capital efficient, and our actions speak for themselves. So now what we are trying to do is we plan to raise capital that will act as a gap filler. There's already a lot of things that exist in the market, but there are also a lot of things that do not exist. So the idea is we build that capability so that altogether it augments the capacity, not just of our one company, but the entire ecosystem scale globally. So that's what we plan to do in the next few years. We have a blueprint for establishing a 100,000 square feet facility here in Hyderabad to propel our growth.
You said that you're looking to be a prime contractor from India. What does this term mean, a prime contractor?
Okay, so in the satellite world, I think the prime contractor is a pretty common terminology. So essentially, prime contractors are the one who design, manufacture to scale, and deploy them in orbit. In the Western world, you've always had prime contractors, so who would do the impossible. Right? For example, just consider the James Webb Space Telescope, or even in simpler terms, you can look at the fighter jets, right? They were all built by the prime contractors who would design, who would work with the ecosystem and create something unique that is needed for the world largely, but is also extremely important for the nation.
Like Reliance Jio is getting into like a satellite internet kind of a business. Bharti also has it. So these companies work with prime contractors to get their satellites out in space.
Wow, that's a good perspective. Yes, they would work with prime contractors, or they would team up with very well established players to get a strong entry point into the market to offer services, or create a large enough entry barrier for others to not pop in between.
And that brings us to the end of this conversation. I want to ask you for a favor now.
Did you like listening to this show? I'd love to hear your feedback about it. Do you have your own startup ideas? I'd love to hear them. Do you have questions for any of the guests that you heard about in this show? I'd love to get your questions and pass them on to the guests. Write to me at ad@thepodium.in. That's ad@thepodium.in.